Okay, we are picking up with 8.2 part 2, and I've got a couple more problems that we want to complete. We looked at prime factorization and factors of a number, what is a factor, what is not a factor, and then prime factorization again, and pulling a common factor, multiplying a monomial and a trinomial, and then pulling a common factor, looking for the greatest common factor, and then pulling it out of a polynomial using the reverse of the distributive property. And that you saw happen right here. So we've got factoring a polynomial model here. So we sometimes have polynomial models where in this one we have a helicopter pad, and we know that the square helicopter pad for landing is measured by 6 times a value of x, some number. And the radius of the circle that is inscribed in that square has a radius of 3x, or half of the side of a square. So it says a helicopter landing pad or helipad is sometimes marked with a circle inside a square so that it's visible from the air. What is the area of the orange shaded region of the helipad at the right? I don't know if that's how you say it, helipad. Write your answer in factored form. So the first thing I'm going to do is look at the expression, write an algebraic expression for the area of a square. Now, we've done this. We have to say, well, what is the area for a square? So area is A, and that's equal to side times side. We often just say area is equal to side squared. And so the side, in this case, is equal to 6x. So we just need one side. The other sides are all 6x as well. But we're going to take the area, then we're going to have area is equal to, then we're going to plug it in for s, and that means we're going to square whatever s is. We're going to put in 6x. So that gives us, remember, you have to distribute the exponent here to both the 6 and the x, and that would make sense because you would get a 6x squared times 6x squared if you square something, so you get 36x squared. So we get the expression is 36x squared, okay? And then we want to write, so we start saying, well, if we want to find the area, let me back this up a little bit. I'm asking you questions, but they're specific for a reason, because I think of the end in mind a lot of times. I want to find the orange area, but isn't this a takeaway where we have the area of the orange, we'll call it, orange area, is equal to the area of the square, and then take away the area for the circle, okay? So I'm finding the area expression for the square, so we have that now. Now the next one says write an algebraic expression for the area of the circle. So for the area here, the area for a circle is pi times r squared. And that just means pi times r times r. So then what is r? R is the radius. So I didn't say S was the side on the last one, but R is the radius. So we get R is equal to 3x, right? So we're going to take our formula and we get area is equal to pi times radius squared. And so using that formula, and then we get the area is equal to, we're going to take and distribute the exponent to both factors. That's one of our exponent rules. And so we get pi times 9x squared. And so we're going to rewrite that now to the area is equal to 9 pi x squared. So that's 9 pi x squared. And both of them have an x squared in it. So we kind of like that in math. I'm going to scrunch this down a little bit, though. Okay, so all we did was we took the function, this is area is equal to pi r squared, r was equal to 3x, and I'm just moving this around just to kind of put it around the actual input. So I've got, just to review, I've got area is equal to pi r squared, so there's the area, which means that area is equal to 9, or pi times 9x, the quantity, because I squared 3x, and then I get this. So now, check, I got that second one. Now we want to complete the problem with using our idea here. I'm going to move this over. So we know that that to be true. Area of the orange is going to be equal to the area of the square minus the area of the circle. So the area of the square is 36. So the area of the orange is going to be 36x squared minus 9 pi x squared. So now I'm going to pull out an x squared. Now remember, it's x squared times, see how there's an x squared factor in both? That means we can pull out an x squared with the distributive property because it is a factor of both terms here. And so if it's a factor of both terms, I can pull it out over here on the right. So now what's left in the first term is 36 minus what's left in the second is 9 pi. Now here's why I did that. Complete the problem below. Well, complete the problem solving model below. So it said in the problem, it said write your answer in factored form. I answered the question with the first 36x squared minus 9x squared, but since we wanted it in factored form, I had to pull out the x squared. Now you could write it as x squared times 36 minus 9 pi, but you don't have to. Okay, now you have a lesson huddle, so I'm going to ask that you simplify these. Now that means you're going to use the distributive property and get simple monomial terms. So you'll end up with either a monomial or a trinomial, but you're going to distribute. So pause your video and try the lesson huddle. And then we've got a few more problems on the back that you can go through. The lesson huddle goes these 3 and these 3, and you can check your answers when you're finished. Okay? And I will submit this worksheet to Schoology. You can check your answers with that, okay? And I think there's a mastery assessment too. All right, have a great night, and I'll see you when I see you. This is Alan out.